Welcome to day number 2 of our mini course, and today I want to spend the first part of the hour talking about typing mathematics, because yesterday we were talking about typing straight copy. It occurred to me in the middle of the night that I lied in one respect yesterday, and being a very honest man, I have to admit that what I told you about quotation marks is almost always true, but not always true. Namely, that if you type two things to get opening quotes, but it depends on the font you're using. Some fonts don't have that built in. The same thing with dashes. If you're using our so-called typewriter type font, and then you type in two hyphens, you get two hyphens. But if you're using an ordinary kind of font, you type two hyphens, you get an end dash. And so each font actually is what tells the designer of the font has told TeX what combinations are there. TeX doesn't have these things built into it. So people can make up fonts that do strange things, like our Cyrillic font has special combinations that you type to get special letters in Russian. In fact, on the Russian font, if you type two open quote marks, you get a Russian-looking quotation marks, or French, it's a little tip V symbols and stuff. So each font has its own built-in things like that. So, otherwise, TeX couldn't possibly know how much space to leave out between those two quote marks for each font. It would look funny in some fonts, not. So the designer of the font really tells TeX all about all these multiple letter combinations that are there. Okay. Otherwise, I think I told the truth yesterday. Now, today I want to get mathematics, and I decided that what I would do is I'd go to my beloved calculus book that I used when I was a freshman in college, since this is a kind of mathematics that seems to be common to so many technical papers, and this book is actually quite a beautiful piece of typography, and that's one of the reasons I guess that I always that I went with the publisher I did, because I remembered that I liked the books that they printed when I was a student. And so I looked at the book and I said it's about 800 pages long. So I'll just go to page 400 right in the middle of the book, and I'll use that for my example. So I looked at page 400, and then but I have to tell you this because I'm being very honest. You see, at least I'm telling you I'm being honest. But on page 400, it was a little bit too complicated for what I really wanted to present on the first lecture. So I decided, okay, well, let's look at page 200. Okay, so page 200 is what I want to start out with as a first example of mathematics. We'll get to page 400 later, though. So page 200, can we have it on the screen so you can see what we happen to be in page 200? It's called Applications of Integration to Physics, and it starts out with 3 illustrations. Well, now, I'm not going to tell you how to do these illustrations with TeX. In fact, you can't. I mean, TeX isn't going to draw a very, very nice line like that. However, one of our grad students did a thesis this last spring, which actually would make all 3 of these figures very nicely. And another one of our students, David Wall, if you look at his thesis in the library, he actually did all of his illustrations in his thesis with the Metafont program as if these were letters of the alphabet, and made a big type font, especially for his thesis, just containing the illustrations in it. But anyway, we're going to start on the next line after the illustrations, and just to say that work is in progress on how to do technical illustrations also, but for now let's assume that we've got a good art department that's going to do this all beautifully for us with their airbrushes and all this thing. Now, okay, so now I want to go through this page, and maybe I'll try an experiment where I'll just ask you to tell me. I might go through the class here, and unless people are too nervous about it, and I'll just ask them to tell me how we would type each of these things, and then I'll uncover the answer as we go. Let's see if I can set up a little thing here. Now, okay. So let's see if I can work this out. So I started out my file by saying input basic. That's what I suggest that you all do on your sample file. Then the next line, I I added this next line afterwards. I saw that I was going to need a new font down here that isn't in BASIC. See where it says example 1, caps and small caps font. And so I input a new font there. Forget that for the time being. And the next line is something I told you about yesterday, that I could use a double arrow. This is a special incantation that you can put at the beginning of a file. You don't have to copy it down now because there will be a handout later that has this all in it. You don't have to copy down any of this, actually, I think. You can just pay attention to you won't have to worry about copying. But this is an incantation which says when I type a double arrow, it's going to tell TeX not to break between those two words at the end of a line unless it's absolutely necessary. So I started out that way, and then now we got to get to the beginning of this line here. Well, this first sentence, of course, there's nothing very interesting about it. It starts out, so we just type it in, right? Other applications of the moment of inertia to physical problems are discussed.
How do we get the paragraph indent done?
Okay, the paragraph indent is part of BASIC format. BASIC format sets up a certain paragraph indentation. It's actually, I think it's about almost 2 M's, which is maybe too large. If you don't like it, you have to change it, and you say par indent 1 M or whatever you want for your paragraph indentation. But BASIC has its own idea as to what a good paragraph indentation is, and it's sort of a style that's been preset for you. All of these other facts of the style, though, can be changed. For now, we're just going to assume that somebody gave us their favorite style. So BASIC, every paragraph will be indented. What the problem is, if you don't want it indented, then you have to say don't indent. Okay. Now,
You have a blank line
so a blank line at the beginning, I wouldn't have even needed this blank line because at the very beginning, TeX is ready for a new paragraph. But a blank line ends a paragraph and puts you back into the condition you were at the beginning. Okay, so at the very beginning, so it's always so in other words, the fact that I typed this capital O here and it wasn't preceded by a backslash, it says, oh, this is the beginning of a paragraph. Anything, you know, when I said center line or something else like that, it wasn't starting up a paragraph in yesterday's examples. But this capital O is what switches it into a new paragraph. Then when we get to the end of that paragraph, there's a blank line there. It goes back to the starting condition, saying, so then we can give instructions like give a little extra space. It was coming in, okay. So now, now, does anybody remember what I do when I get to this next line when you say, I guess we need it a little bit larger, yeah. I'm going to tip it a little bit so that you can see more of the line. It's okay in your screen? That's okay. I'll tip it. I think it's okay. You can, it's neat to look out at the audience here and see everybody. Okay. Now, if I go like this, what do you do? Okay. All right. Yeah. All right. Anyway, what do we do to get this in italics? This is a book by Sears, Mechanics, Heat, and well, I'll go on, Sound. Okay. Now, how am I going to get that into italics? Does anybody? I'll go sequentially through, and I hope you don't mind if when it comes to your turn, it's either a very hard or a very simple question because we just do it for fun. First, pick up your mic and.
Okay, I would write open parentheses C Sears, comma, and then begin with an open brace.
Open brace, yeah.
Backslash SL, space, and then within the group mechanics.
Now why do you say backslash SL?
For slanted.
Slanted type, okay. And there's also, but this is in italic type.
This is for IT?
So I haven't talked about the difference between slanted and italic type. Now, slanted type and some people think it's the same thing. Now, there's two different styles of type. One is just like the ordinary Roman, but it's tipped like your heads are tipped, right? And the other one is quite a different style. The beginnings of the letters go in strokes like that and so on, and that's italic. Now, typically, italic is used in mathematics. Let's take a look at, here's an example of the TeX output for this page. You see the X there. That's quite different from an X that you find. The M here is quite different from that M, okay? But now, up here is an example of slanted type. You look at the A, for example. Well, let's see, do we have anything? Here's an M. Do I have an M? No, just an N. Anyway, slanted Roman type is a different thing. So now this is something that you might not like. Somebody might just prefer to do it the old way and just use italic. And you'd say IT for italic. In this example, I used SL for slanted, just to illustrate the difference, so that I could tell you about the difference between italic and slanted. And I've been experimenting now that it's easy to do with computers. It was very hard to do with the old printing equipment, but now that it's easy, I was experimenting with using Roman type for normal text, slanted type for emphasis or for titles of other books, and italic type for mathematical symbols. The reason to have a distinction for this is important in mathematics, usually because a statement of a theorem or a main result is often in italics, the same as the variables, and you can't tell the difference between the formulas and the italics in that case. But if you have slanted for the statement of the theorem, then the formula will still be distinguishable from the statement of the theorem. And on the other hand, people say, well, you shouldn't go overboard and change fonts all the time. Why have so many fonts? And it's true, you can go overboard, but slanted seems to blend reasonably well with Roman. And so some people have gone halfway, and they like to use slanted just for titles of books and things in the bibliography, but they use italics for emphasis and italics for formulas or something. Anyway, you have this extra freedom now that you can use or not if you want. And in this case, in my example, I use slanted, which comes out slightly different from this, which is italics. Okay. And now, where do you put a close brace? You said open brace before the mechanics, but where do you close that brace?
I would put it immediately after the D is sound. After
the D and sound. Okay. Yeah. Otherwise, you get this comma in italics. Now, you do get the commas in mechanics, heat and sound, and if that was actually, if you look closely here, I think those are italic commas, but it's very difficult to notice, and you can get a headache. And so often they'll say put an italic on a comma there, and they're not sure what to do on a semicolon. Sometimes they make the italic a semicolon, sometimes they don't. Now, if this were a semicolon, we could get into trouble because the D might bump into the semicolon, okay? And there's a little thing that I haven't done in this example because it was followed by a comma and it didn't arise. But if at the end, after you're doing italics and you end with a D or something that looks like it's going to stick out, before the right brace, you put // which is called the italic correction. Add the italic correction, and this will add whatever is the appropriate amount of space for the preceding letter, so that in case you wanted to follow that by a semicolon, it wouldn't bump into it. Okay, but you do this like if it's followed by. I'm afraid you have to use your own judgment on this. Sometimes you want it, and sometimes you don't. And TeX will do it. Will look sometimes. Some fonts will say look for a quote mark follow or something like that when it's more important sometimes. But usually you catch this if there seems to be a little bit too a bad clash all of a sudden. Then you put in the italic correction. That's a refinement that sometimes you notice. Anyway, okay. So that's an example. I'm sorry if I bring in always the hard cases. I'm being a little too honest, I think, sometimes in this lecture. But you've got to also realize that all rules have exceptions, and sometimes I can probably go overboard in thinking the exceptions when I state the rule. Okay, now anything else coming up here? Well, not really so bad. And then we get to a displayed formula. Now this is a little bit hard. I'm going to start with simple formulas and then go back to the display in a minute. So we're going to come back to this display in a minute. But meanwhile, let's go on to the next line. It says, in which I is the moment of inertia and I is a simple formula. You see that letter I all by itself? That is a formula. It's a mathematical formula. It happens to be a little rather trivial, but it's a formula. So, Carolyn, how would you type that one? Any idea?
Is it just a slanted I?
Okay, you could say slanted I, because that's what it is, a slanted I. But that's not psychologically right. Okay.
I don't know.
Let me explain. In the first place, I want to point out that since mathematics used to cost a lot of money for typesetting, TeX convention about mathematics is that mathematical formulas are surrounded by dollar signs. Okay? So you put a dollar sign before and after a mathematical formula. Okay? Now, try again.
A dollar sign, capital I, dollar sign.
Yeah, that's it. Okay, so there's the so that did it. In other words, it's a very simple formula. You just oh, can we have it on screen? Okay, so it's just dollar sign I, dollar sign. All right? Now inside of the dollar signs, special rules apply. Yeah, in mathematics, special rules apply inside of dollar signs. And TeX will do what's 99% of the time the correct thing for mathematics, for spacing and so on. When you first see a printer that hasn't done mathematics before and he comes up with formulas, they look funny to a mathematician, but it's hard to say exactly why. They just look funny. And then the printers who did know mathematics will have learned over the years the conventions for putting the space in the right place. And TeX has also learned these rules, and again, all rules have exceptions, but 99% of the time it will do the right thing for you in the formula. And we'll see only one or two exceptions today that the manual talks about them. Now, of course, in a formula like this, there isn't much room for error. I think any printer would get that one right. Although the italic correction was added, in fact. I mean, actually, the I doesn't just the baseline of the I isn't centered. The italic correction is centered by. Now, another thing is inside of the dollar signs, you don't have to care about spaces that you leave in there at all, because TeX thinks it knows better than you. So if you put spaces in there, it's going to ignore them anyway. So you could say dollar sign space capital I space dollar sign, and it would still come out exactly the same. But the spaces before and after the dollar sign are part of your ordinary paragraph, and if you left out the space after that dollar sign, it would throw the words together. I is or something like that. It's I am or something like that. Now, okay, the next line we got. This is too simple to ask you, Jeff. So G is the acceleration due to gravity. L is the distance. Notice you use an L here. That comes out to be your italic L. It's not confusing with a 1 like it is on a typewriter. But if somebody wrote a script L, and you definitely wants a script L, it has a loop in it, then you have a control sequence for script L, SCRL, which would give you the script L. Now, actually, when I'm writing a manuscript and giving it to my secretary, I'll typically use a script L so that it won't look like a 1. But then she'll type it as a script L, and then I'll remember saying, actually, now that it's going into TeX, it's okay. Italic L's look all right. And then so now I tell her, when I mean a script L, I'll put a note on the side saying, I really mean a script L today. But usually italic L's are okay in something like TeX, but on your other typewriter maybe not, unless you had some kind of a selectric where you're changing the balls or something. Okay.
Question.
A question?
What you raised about script L and L, how do you actually type in a dollar sign or a backslash if you want those to appear as part of the text?
If you want a dollar sign, you say backslash dollar sign. Like if you wanted to say $1, if you're writing you're writing a paper on economics, something like that, and you have to say $1, like you could put this outside of it. So you have to get into math mode, and then this is treated as a special character in math mode. And there are a few of these symbols that are actually treated as mathematical symbols, even though sometimes they aren't considered. I mean, there's a pound sign too, a sterling, I think you call it, STRL, if you're in England, and there's a sign called section. These are all listed in the manual. There's a sign called section that goes like that, and that is considered a mathematical symbol. So you put dollar signs around it in order to get it. Okay. Phyllis, you had a question? Remember to use the mic. Oh, that's right.
I type it more than you do.
In fact, that's right. I've forgotten this one completely. It's LSCR. Thanks very much. In fact, otherwise I wouldn't know, because otherwise the uppercase, there's an uppercase script L too, and TeX wouldn't know the difference between this and with an uppercase. So the TeX knows the difference if the first letter is uppercase or not, but the other letters it doesn't. So you're right. L-scr this way with a small L. Okay. All right. Thank you very much. That saved me at least an hour of sleep tonight. Okay. Now, now let's look ahead here. There's a little extra space between these two. Okay. So, how would we get that, Jeff? Oh wait. I'm sorry. Before I go to that, no. This will be your question. No, Jeff. Excuse me. Look at this dash in here in the figure 511. Do you see anything unusual about that? What is there anything different to type when you type the C figure 511 here?
It is slightly longer than a...
Yeah, right. This is an N dash. This is one of the contexts where N dash is typically used. Printer won't use a hyphen there. Good proofreader would think it looks funny with a hyphen there. So how do you get an N dash?
So you'd use two
yeah.
small hyphens.
Okay, right. Okay. And then I also put my double arrow between it because that's to avoid, first of all, getting an too much space after the abbreviation FIG, and also it wouldn't break a line. In case this came at the end of a line, it wouldn't put a break between fig and 511 on the next line. All right. Now, on the other hand, since this is an N dash, it's possible that it would break after that and before the 11. That would be a pretty bad, pretty lousy looking break. And if it did that, then I would go back and put that in an H box saying forbid the break. But the chances are pretty bad that it'll ever happen. TeX only chooses hyphenating things if it's really necessary. So I didn't bother to do that. Although it's possible that I would get a break after that N dash that I didn't want. Okay, next question. How would I get this little extra space here? Notice I did leave an extra line here because I came to the end of a paragraph. Okay, but now I want to leave a little extra space between this and the next paragraph.
I would use a backslash V skip,
Okay.
however many points.
Of something, yeah. Okay, well this is actually typical style here would be about 3 points extra. 3 points doesn't seem like much. 72 points to an inch. 3 points is 1/24 of an inch. Doesn't seem like much, but actually a little space actually is quite noticeable. 3 points worth is certainly noticeable. So V skip 3 points did it. Now to get the next, this next is in 9-point type instead of 10-point type. This example is in smaller type size, but BASIC only has one type size, so I just left it in the same type size. If you're setting up, though, for a book, your font designer would tell you at this point, actually, he would probably have a special style that you would go through for examples, and that would automatically switch you to 9-point type and change all the fonts. But I'm going to ignore that and just continue on in 10 points. So let's go on. Example 1. Does anybody know what I do to get to start out example 1 without an indentation? You say no indent, right? So I say no indent. That's another way to start a paragraph. Is say no indent, and that starts you off in a paragraph, and there's no indentation in the paragraph. Well, then there's caps and small caps. I said I invented a new
Excuse
font.
me, Don.
Yeah, Arnie.
Do you put a slash before the no indent?
Here it is. Yep, here it is. You see that? No slash, no indent. Because otherwise it would type N-O-I-N-D. It would be indented even. Yeah. Okay. Now here I had a caps and small caps type used. Okay. And so here I'm doing. So I switched to font M. Now the backslash colon is a way of switching to a font. I could have also made up a control sequence, meaning switch to caps and small caps font. But I just showed you this because I defined font capital M at the beginning of this page to be this font CMCSC, which is a caps and small caps font. If you go over the room by the Dover on the wall, there's a book that has examples of all the fonts that are available now. But I only needed this. Actually, it's not in BASIC, and I don't expect you'll need it in your own case. This is just to mimic what's in the book. Typically, the designer of the book would even set up a special control sequence just for examples. So you would say begin example or something like that, and then you type example 1, and the control sequence would take care of everything. It would do the no indent. It would insert the 3 points, and it would also put a little extra space after it. And that's the next thing I want to talk about. This quad here. Now this is a little extra space after that example 1, and the book designer and 1 quad of space is about is the same width as an M dash, but it's blank instead of being a dash, and it depends on the font that you're using. So I said quad here. That gave me a little extra space after the 1. Well, now the rest is pretty straightforward, but I'm just telling you the new things that are coming along. Here we have a simple math formula L. Okay, now we're going to get to a real math formula in a minute. So then we go into solution. Okay, you can already tell what's going to come there. We ended this paragraph, then we said v-skip another 3 points, and then we said no indent and slanted for solution, or you could have had italic if you wanted for solution, and a quad there. Okay, now we're typing away, and now we get to here's a slightly more complicated formula. Can anybody read this? Suppose the rod coincides with the x-axis. Let's get this a little larger. We can, yeah. Okay, now here's x-axis. How would you type that? Let's see. Here, I forget your name. Oh, you're next. Yeah. Okay.
You would put 1 dash in between.
Yeah. This is a hyphen, not an M dash. But how do I get the X? I don't just type an X.
/IL space X.
Well, I would use a $sign. Okay. But that is yeah. So I would use the $sign. And type it like this, okay? X-axis, okay? Oops, I'm showing the next answer. All right, X-axis, all right? So that's, again, it's a simple math formula, but you can combine that with words if you want to, because there's no space after it, okay? Now, where are we here? Okay, from x equals 0 to, all right? Now, this whole, x equals 0, that whole thing is an equation. And so typically there'll be a slightly different spacing around the equal sign, but TeX is going to be the one that's going to be responsible for putting in the spacing, the proper spacing around the equal sign. Okay, so next, how would you type that little equation, x equals 0? You have the mic? $sign, X, yeah. Okay, but then I do put the whole thing inside. So I say $sign X equals 0, and then another $sign, and then TeX will automatically know the right amount of spacing and how much it should grow and shrink as appropriate for an equal sign. Okay, from x equals 0 to x equals L, and so that's again very simple. All right. I see that it's going a little slowly, so I'm not going to go through the class anymore. It was fun for a while, though. Now, divide. Okay, now divide the interval. Can you predict, though, with me exactly what's going to happen? Divide the interval 0 less than or equal x less than or equal L into. Okay. So here we see a mathematical formula. So instinctively we type $sign, then we type 0, then less than or equal. We happen to have a less than or equal on our keyboard at sale. It's very hard to live without it once you've had it, but if you don't have it, you can make up a control sequence that will say LEQ or something for less than or equal. But in my examples here, I'm doing it all at sale where we have our less than or equal symbol, and so we type that this way: 0 less than or equal x less than or equal L. Okay, and into subintervals of width delta x. Now here's something. We got a Greek letter. Delta, okay? Now, those people who have done a lot of technical typing will probably know from other people that it's called delta. Other people done a lot of technical typing never learned the name of it in Greek, but they know what it looks like. and they're used to they're used to it by triangle or whatever they want to call it. Okay. Now a list of all these symbols is in one of the appendices of the manual, and where if you see a symbol that somebody throws at you that you don't know the name of, you can look it up. It's Appendix F for all the font information. It's in the back of it. And then there's also, this is a capital Greek letter, and it's called delta, and we type that as a capitalized D, capital delta, okay, X. Now, I have to mention that I had a debate with this with one of the men who does a lot of typesetting of mathematical journals, and he says that it's easier, that he prefers to have completely sort of random names for all these special characters, that his typists learn, because that gives them a feeling of power over the mathematicians. And they get more job satisfaction from that. But since we're expecting also the mathematicians are going to understand a little bit about TeX as well, so we chose our names for these symbols the same as a mathematician would use, a capital delta. Okay, so delta X, there they are. They get typeset that way. Okay, now here we have delta M, same thing.
Question?
Question, yeah?
Obtain the space between the end of the delta and the X there.
Okay, now what if I didn't put a space in there? Anybody got an idea? Error message, undefined control sequence, deltax. It doesn't understand deltax, yeah. So here's a case where spacing inside the dollar sign did make some difference. If there wasn't a space there, then the control sequence would change its name. Yeah, so that space was essential. You could have put two spaces there, or spaces before the delta, or something like that. It wouldn't have made any difference. But that one is necessary just because it's a control sequence, right? Okay, so delta M, the same thing. That delta M denote the mass between X and X plus delta X. Okay, X plus delta X, you see that's typed in this obvious way. Okay. And the moment of inertia of delta M differs from X squared delta M by an infinitesimal. Now here is, I think, the only exception, well, one of two exceptions I'll talk about today in mathematics typing. That is, when you have a formula, if you had just typed this X squared delta M to TeX, it would not have put a little space between the X squared and the delta sign there. But it's been traditional in mathematics that whenever you have a delta, an infinitesimal specified by delta or by D, like dm, you put a little space in front of it to separate it off from the rest of the formula. So somebody would say x dx. There will be a little extra space there between the x and the d than if they were all together in a formula meaning x times d times x, because dx it means something to mathematicians. So when you're typing calculus things, you have deltas or something else in front of it, you have to sometimes remember that there's a space there that's a matter of judgment as to whether this is sometimes you put it in a fraction, you don't. If you're saying delta x over delta y, you don't put it in front of the delta y. So I had to adjust the spacing there. But first of all, the x squared, I guess I ought to mention that. To get a superscript, you say up arrow. So up arrow 2, and gives you x squared. But then I put this thin space between, after the 2 and before the delta. So this backslash comma means a thin space. Backslash comma is what you stick in if you like a little more space. The backslash exclamation point is the opposite. It means take out a thin space and put it together back up by a thin space. So backslash comma is a thin space. There's also a thick space, backslash semicolon, which is the typical space that you actually have around equal signs and around unequal signs. There's a thick space. If you can see the thick space here after the 0 and before that less than or equal sign. That's a thick space. The thin space is typically used in front of there. It's a little bit thinner. It's a space between, if you have something like log x, there's a thin space between the word log and x. TeX will put that one in for you automatically. But here I had to put this thin space in because it's a convention in calculus. Before dx or delta x or something like that, you put a thin space. Okay, now here's the next one. Delta x right arrow 0. Now, we have a right arrow sign on our machine, so we just type it. We just type it easy way. Otherwise, if you're doing it at Score or some other place, you don't have that on the keyboard. At Xerox, I guess you don't. You would type RT arrow or whatever they call it there, and you have a control sequence that somebody would have to make up for if you don't have it. That would get you this symbol. But as far as TeX is concerned, this symbol is pretty much like an equal sign. It has the same spacing around it as equal signs do. Okay. For a homogeneous rod of constant cross-section, also delta M equals rho delta X. Here's again a thin space after the rho. Okay. Now, I typed rho thin space delta X. Rho is one of those characters I don't have on my keyboard, so I had to type RHO. Okay. Didn't have delta either, for that matter. And then M over L. Rho equals M slash L. Is, I guess, the obvious way to type that. Okay. Now we get to something more interesting. Hence, now we get this. This is a displayed formula. Now, displayed formulas are even more expensive. So in the old days, so they would. It usually meant a lot of handwork, especially. So we put $2 signs before and after a displayed formula. Okay. So double dollar sign means this is a display. Something that means you stop your paragraph where you are. Essentially, I mean, it tells TeX, it says stop the paragraph where you are. Add a little extra space and center something that's coming after. Okay. Now, let's do this display formula one step at a time. I sub y. So down arrow for subscripts. I told you about up arrow for superscripts, but a down arrow gives I sub y. Equals. That's easy. Now we got this integral sign here. Okay. Integral sign is int. And then integral signs have these other things on which we treat just like subscripts and superscripts. So you can give the superscript first or the subscript first. It doesn't matter. I gave the subscript first. So I say sub 0, super L. Okay. All of these examples, by the way, have a simple one character as a subscript. If it was more than one character, I would just put the whole thing in braces. TeX will, if you don't put it in braces, TeX assumes the very first character is the superscript. I put a space after this L, but that didn't mean anything to TeX. This space is in a double dollar sign, same as in dollar signs. It doesn't matter. A space, TeX won't, will ignore that space. It does its own spacing. Here's x squared. Okay, superscript 2, and then in front of the dm, I want to have a thin space. This is a calculus convention. In front of a differential, you put a thin space. So I put my thin space in there. Comes the equal sign. Now the next one is almost this is trivial. This is integral sub 0 super L x squared. Here I didn't leave a space between the L and the x, just to show you that TeX doesn't know. If the L isn't in braces, it's only one symbol long. The superscript only lasts one symbol unless you put a brace there and give a more complicated formula. And then x up super 2 row, again, no space there, so that's why the superscript is only a 2. And a little thin space before the dx. Okay. Now we got something new with fraction here, rho L cubed over 3. What you do there is you use the word over with a backslash in it. In fact, it looks very much like that one, except it's this one. And now I put the whole thing in braces. I put the whole fraction in braces so that TeX would know where the fraction begins and where the fraction ends. And then I said rho L cubed over 3. Double dollar sign to end the display. The whole thing gets centered and properly spaced out. Okay, now this is the formula, and the over, you say how does over know how far to go? What goes over what? Well, it goes to the left till it gets to a left brace or something. There's one other case called a backslash left that would stop over. If I didn't have those braces there and I said rho L cubed over 3 without the braces, it would have taken this whole formula here and then put a bar over it and a 3 underneath that. It would have had that long thing. It wouldn't make too much sense mathematically, but maybe someday we'll think of something that it means. But that would be over with a 3. All right? So that's a displayed formula. Now, if this same formula had appeared in the middle of a text without the double dollar signs, it would have gone right in that paragraph there, and it only had dollar signs around it, and it also TeX would have set it in a different style. TeX would not have used such big integral signs in the middle of a paragraph as it does in a display. TeX would have chosen a small integral sign instead of a big integral sign. So there's a different style actually used in a display than in the middle of a paragraph. And there's 4 styles altogether. There's the display style, which is your grand and glorious style where you use big signs and you raise superscripts a little bit higher, actually. Then there's the TeX style, which is what you normally get in a paragraph. Then there's the style that's used in subscripts and superscripts, which is smaller type size, and you don't put thin spaces in. You don't put spaces around plus signs in the subscripts, and TeX knows that, and or equal signs, for that matter. And then there's the 4th style that's called the script style, which is for the subscripts or superscripts of subscripts or superscripts, and that's script style is used for all the remaining levels. If you have 2 to the 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 2, first 2 is in your regular size. The next 2 is in like 10 point. The next one maybe 7. The next one 5 point, and then you stay in 5 point afterwards. But you get smaller for the first. There's these 4 styles, and usually the styles are chosen automatically appropriate to the condition. If you put it in double dollar sign, you got display style. If you got single dollar sign, you got TeX style. TeX style has smaller integral signs. Okay, now let's continue though. It says or, and then we have this other formula, and here is another. This other formula shows another difference between the styles, because look at this 1/3 here. This 1/3 was not in the same form as that fraction, L cubed over 3. The 1/3 is actually, if I had stayed in the display style, it would make this 1/3 as a big 1, a big bar, and a big 3. Okay. But that 1/3 is really in TeX style. So in order to indicate that, I had to so the second line, the only tricky thing about the second line, I did almost the only tricky thing was that I went into TeX style at the end of it. And so after this equal sign, I said TeX style 1 over 3 ml squared, and that got me the 1/3. Otherwise, the 1/3 would come as, it wouldn't look so bad that way, but I wanted to mimic what they had here. Oh yeah, the other tricky thing about this is I got big parentheses around here. If I had just typed the regular parenthesis and then done my M over L, then that would be a teeny tiny little parenthesis. Because as far as TeX knows, the parenthesis is just any other symbol. They don't have to match particularly because it's surprising to mathematicians how often, but it turns out we often write formulas that have a left parenthesis and nothing matching it on the right-hand side sometimes, or usually a left brace and nothing matching on the right-hand side, or something like that. Often happens. In fact, TeX doesn't insist that there be a right parenthesis for every left parenthesis. Sometimes there's a right bracket or something like that. But TeX does. But if you wanted TeX to choose the right size of left parenthesis, then you can say left \left and \right. And then it chooses the size based on what's in between them. So if this were so here I said \left, and then I gave the symbol that I wanted to be a left of, and it's a left parenthesis. And then I said \right and give a parenthesis for a right. I could have made that some other symbol after the right, and that says choose the proper size. If there was a whole matrix or something inside there, it would choose some great big huge parenthesis for it. But it chooses the size for that formula. So that's the other thing about this line. Okay, now I think I'll go on.
Question?
Question?
Why didn't you need to do that with the integral sign?
Why didn't I do that with the integral sign? Because the integral sign is considered a operator that changes to its sizes in displays, while parentheses are considered delimiters. There's a difference between operators and delimiters. There's two kind of things. Integral sign is considered an operator, so is a big sigma sign, a big summation sign, and these are also explained in that same appendix. There's a list of about 10 operators and a list of a bunch of delimiters, and those are considered different things to mathematicians. The spacing is different around them and so on. So you learn to distinguish one from the other. The delimiters are the things that are for grouping, like parentheses, typically. Parentheses,
Question?
braces. Yes? I forgot your name.
Lorraine. Why didn't you have to put those, did that backslash left parentheses also is used as a brace? Why didn't we have
Yeah.
to put braces to that?
Yeah, that's right. Backslash left and right, since they have to be matched just like braces do, then over knows not to go outside of backslash left and right. That's right. Over, yeah, that's a good question. Yeah. Over, no, it wouldn't hurt to put braces in there, but it doesn't help either. Don't need them in between left and right, you don't. Yeah.
Another question?
Another question, right?
Yes, on the text style, does the text style just apply to the next unit?
Text style applies from then on after.
So actually the whole 1/3 ML squared is all in text
That's
style?
all in text style, that's right. If I wanted to get back into display style, I could have written right here, I could have said disp style after. That would be almost indistinguishable, but the superscript of the two would have moved up. Actually, they aren't in display style with that too. A superscript in display style tends to be a little higher. Well, I'm not sure what they do the same in the numerator. But on the main line, that superscript 2 on the X there is slightly higher than it would be in the text. It's a funny thing, but they do that, and so does TeX. Okay, so if you wanted that in display style, you can revert to it again, or you could put the whole thing in braces like this. Okay. It would have been a mistake though to put braces and then say text style 1 over 3. Because then the 1 would have been in text style, but not the whole fraction, okay? So here's 2 sets of braces would have done it, okay? Good questions. All right, now let's go back to this first equation here. This one had a square root in it. This is a display, also has a number. And how do we type that? Well, the answer is, I typed it like this. T equals 2 pi, well actually there's also a pi on the keyboard, but I wrote it out. SQRT for the square root symbol, and then a brace because it's a square root of more than one thing. If I had square root of just one thing, I would just say square root 2 or something, but I can put braces, and then I over MGL is the thing that I'm taking the square root of, okay? And then to get this equation number here in the right margin, EQ number 5. And TeX will do the right thing. If it doesn't fit, it'll drop it down in lines and things like that. So that's the way I typed that one, and there's a similar formula at the bottom of the page. Okay, so now what happened when I first put this into the, I did this yesterday morning, and I first put it into the XGP, and so I got the thing out, and it looked actually pretty much like the printed book. In fact, I was amazed that it came out looking, I was lucky this time. I didn't have any bugs the first pass. But but looking at it, there was one thing I thought I would like to change, and that is I would like to leave a little more space before this comma. This comma looked a little too close. Sometimes it does, sometimes it doesn't. It depends on the formula and the environment. I mean, if this hadn't been such a tall letter L there, it probably would have looked okay to me. So I decided afterwards I'd put a thin space there. So that was my second proofreading. You know, I look at something and I say, well, stick that in. So it's so easy to put in. So I did it. I put a thin space, in fact, between the pi and the square root 2. That's sort of optional, but it looked a little more psychologically okay to have a little thin space there. So I added. So actually, after this first pass, all I had to change was that putting that thin space there, and it looked okay. Now let's go to page 400, and I'll show you why I got a little bit scared about page 400. These are in boldface. So we were switching fonts also in the middle of math mode to get this boldface. Okay, now all this is going to be on a handout that you're going to be getting, so I'm going to talk a little fast, but you'll see what I did. Okay, so tangential vectors. Start out the paragraph just as usual, but make that in boldface. This is an N dash here. Tangential vectors. Okay, I left a quad space after the title. As the point P moves along a given curve in the XY plane, we may imagine its position as being specified by the length of arc S. Now, actually, this is a case of a psychologically bad break. I could put the double arrow in there. It wouldn't be a good place to typically mathematical convention, length of arc S, or, you know, the integer n you don't want to break between the descriptive thing and the symbol. But on the other hand, you say we see that n is, then you wouldn't want to break between n and is. So sometimes it's before a short formula, sometimes after. But typically a short formula, there's this psychologically bad break. You might, if you're fussy, put that refinement in. Anyway, some chosen reference point p sub 0 on the curve. Okay, then you get a vector with boldface in it, and here's the way I had to type that. I had to go out of math, inside the formula I had to make a box in order to get the boldface R. So I said H box of BF of R. And that made, now H box, and I'll talk more about boxes later, but that is sort of a general purpose way to get TeX to go to typeset something that goes in a horizontal line. Or in this case, R was only one symbol, but if I had several symbols, they would all get put into a box. And then put this horizontal line into a box, and treat that box as a single unit, and that can be used in the middle of a formula. So I said H box boldface R equals H box boldface I X plus H box boldface J Y, and I got all these this R, I, and J are in boldface in that formula. Okay, from O to P of X Y, and that's a capital letter O, and P of X Y. If you look carefully, there's a thin space after that comma there. And TeX does that for you. It does, after that comma, that thin space got in. Question, quick?
Yes, excuse me. What would have happened if you slash H box but left the braces around it and everything else?
It would have said, I would have got an error message saying you can't do that in math mode. You can't change fonts in math mode. Okay, so boldface is a switch of font, and we're going to talk about error messages tomorrow. The whole lecture tomorrow is about error messages. Okay, now. Then I got tired. Then I looked ahead and I saw boldface all over the place, and I said, "Uh-oh, I wouldn't want to type H box of BF. It's going to be a real nuisance." Okay. So then I made myself a nice little trick that a wizard would tell me how to do. That I could just type an infinity in front of something I wanted to be bold. So I made up a special thing that those people next week will learn how to do. But the gist of it is, from now on, I can just type infinity in front of it, and it's going to, and that infinity is, from now on, I can't use it for the infinity symbol anymore, but I can use it to boldify whatever comes after. So to get the dr by ds, I just put it, to get a bold r, I put it in the infinity in front of the r. Okay. So now I kept on typing this, and I got to use these infinities quite often. You see, delta. Bold R over delta S, and so on. Infinity I delta X over infinity S. That's this formula here. Okay, so I was getting a lot of boldface variables just by typing a single character in front of it. It was very nice. Okay, and then I got to this, and I said, "Uh-oh, what is this funny symbol over here? I don't have that in any of my fonts." And how am I going to do this? Okay, so now we have this Metafont program that allows you to design a new symbol. But what I actually wound up doing was faking it by using a grave accent and putting it on top of a rule, and so I defined anyway a vector operation which puts a vector over things in a half arrow symbol, which was all based on a whole bunch of spacing around, lowering up and down, using a grave accent in the wrong place and putting it together. Now. Again, you just go to a wizard and say, "Give me that symbol," and that's what he does, okay? And, well, I was kind of lucky because it came out looking fine, see? Okay. I had to play around with this twice. First I put the arrow a little too high over it, but it came out okay. All right, so now we're almost done with this lesson, but you see there's something new coming up in... these equation numbers, everything is the same as we've seen before. So when you look at the handout, you'll see that everything is the same until we get to this limit. A limit is something like an operator, like that integral sign that we had before, except that the things go underneath it instead of to the right of it. But you type it just as TeX knows that LIM. BASIC knows that LIM is one of these special symbols, and so. Let me see, I just got to find the way I typed that formula 2 is here. So I typed lim, for \lim to get lim, that's in Roman. It's not italic letters. Those aren't italic lim there. And then subscript on it. Now this time the subscript is complicated. It's not just a single symbol. So I put the subscript in braces, and it's delta S right arrow 0. Okay, so that's the way I got the limit there. And then the thing that the limit is applied to, putting in braces, delta bold R over delta S. And I said equation number 2. All right. And is a unit vector and so on. That's the same thing goes on here. And notice one other thing happened now when we put this arrow over the symbol. There wasn't room for it in the next line, the paragraph. These two lines had to be a little split further apart than the rest of them, and actually TeX does that also, as you see when it came out. You see the same thing. The same thing worked out with this coming out of the thing. All right. So now I mentioned handout, and those are up here. Please get one when you leave. There's 3 parts to the handout. First of all, the first 2 pages tell exactly what code was used to typeset the handout you had yesterday. So you can look at that and see what was to get to what you had yesterday. The secondly is an excerpt of this calculus example we've just done. And the third thing is exactly what was typed to TeX, which produces the calculus handout. All right. One more quick comment. Those of you who have guest accounts on the system, and suppose your initials are ABC, you should say, when you first approach the system, you should say L ABC/TEX. This logs you in with your initials /TEX. Don't just use your initials if you've got one of these new guest accounts. Then when you print things on the Dover, it's going to go into the slot. There's a whole bunch of pigeonholes there. It goes into the slot under T for TeX Guest. You are called, your official name to the system is TeX Guest, and not under ABC, but it will be under TeX Guest. Is where you'll find your output when you print it on the Dover. Okay. Here are the handouts. Hi, here are your handouts. And here's a handout.